And you are very welcome to ESB Science Blast TV, delivered by the RDS. I'm Clara.
And I'm John, and we're extremely excited because we've taken everything that's great about ESB Science Blast and stuffed it all into this amazing, jam-packed TV show.
That's right. As you know, ESB Science Blast is all about asking questions about the world around us. And the thing is, the answer to those questions is usually science. And that's because science is everywhere.
And in this episode, we'll be learning about the science behind loads more cool stuff. Have you ever wondered if Ireland has sharks? Well, we'll be chatting to marine biologist Lucy Hunt, who'll be answering that question and loads of other questions about the sea.
Plus, we'll be carrying out some very cool experiments with our science expert, Mark. And not only does he have experiments you guys can do too, but he also has a very exciting supersized experiment outside the RDS, which is most definitely not to be tried at home.
All I know is that we're in for a smashing time, apparently, whatever that means.
But first, as you know by now, here at ESB Science Blast, investigating questions is what we absolutely love to do. And it's time to do exactly that. Have you ever wondered how wind can make electricity? Well, I have, and I did my own investigation to find out how. But before we see how I got on, how about you guys watching? Do you know how wind makes electricity? Wind. We can't see it, we can't touch it, but we can feel it, and sometimes we can hear it. It helps kites to fly and boats to sail. And one thing's for sure, Ireland has plenty of it. Did you know that here in Ireland, almost 1/3 of all of our energy is generated by wind? That means almost every appliance in your house, like your TV, ovens, radios, John's nose hair trimmers, they're all powered by wind. But the big question is, how can wind generate electricity? So, Colin, we all use electricity, but I'm not sure that we all know exactly what electricity is. So, what is electricity?
Well, Clara, electricity is when we get electrons moving in a circuit.
And how is electricity made?
Well, how we make electricity is we get a copper coil and we get a magnet. And when we have movement between the magnet and a copper coil, we generate electricity. So I have a little example of what we're talking about here. So what I have is I have a copper coil and I have a magnet, and I just have a multimeter which is going to measure the ampage that I'm going to generate. So if I place the magnet in the copper coil, I don't get any signal on the multimeter because there's no movement between the magnet and the copper coil. But when I move the magnet, we see that it generates a small electrical signal there. And that's the basis of how electricity is made.
OK, so how is electricity made for the whole country in Ireland then?
Well, traditionally we've used fossil fuels. So we're talking about using coal and natural gas and peat and oil. But that's been transformed now where we're going to be using a lot more renewable energy, generating electricity from wind energy, from solar energy, and of course from hydroelectric energy. OK, so you mentioned wind power there, but how does wind generate electricity? Well, I talked about we have to have movement between the magnet and the copper coil, so that's really important. And we have an example here, a model of a wind turbine. If you turn it there, Clara, and you can see that that would be what the work the wind would do. So the wind is going to blow past the blades and it's going to turn the rotor within the magnetic field. That's going to generate electricity in each wind turbine. OK, so can this one generate electricity? It can. All right, well, do we go? Yeah, let's go for it. OK. So, Clara, as we can see, the wind is moving the blades and we're generating electricity. And the bulb is lit up. That's so cool. So now we know how electricity works on a small scale, it's time to find out how it works on a large scale. So, James, it's a bit chilly, it's a bit windy up here. Where exactly are we?
We're in Raheenla Wind Farm, which is located on the Wicklow-Wexford border. We have 11 Siemens turbines here on site.
So how exactly do they work?
The wind vane will tell the turbine to look for the wind, and the turbine will face the direction of the wind. As the blades turns, it turns the rotor. The rotor is made of permanent magnets. As the permanent magnets passes the stator, it creates electricity.
All right, because I learned earlier about how electricity can be made with magnets and copper coils. So is that kind of like what's happening here?
Yeah, this is exactly the same thing. And it's larger scale than what you learned about.
And how much energy does one of these generate?
The site on a whole will power over 22,500 homes. So if you bring that down, it's 450,000 cups of tea, 950,000 slices of toast. So that's just for one turbine. That's every hour.
They look really big. Just how big are they?
The turbines are very large. The diameter of the blades is 108 metres, which is actually 2 metres longer than the Aviva soccer pitch. And each one of these blades is 15 tonnes. So that's the equivalent weight of 2 African bull elephants. What's really interesting about wind turbines is scientists and engineers looked at owls flying at night because obviously an owl is so silent when it's flying at night hunting its prey. They designed them based on that.
So what happens if there's no wind?
Yeah, unfortunately, that is one of the downsides to wind energy. If you don't have any wind, the blades won't turn, basically. Luckily enough, in Ireland, though, we get strong winds in the winter, and that's when we have most of our demand for our electricity.
So it turns out a lot of our electricity is generated by using things from the world around us, like the wind, our rivers, the sea, and the sun. And scientists are always on the lookout for better and more efficient ways of generating electricity. But for now, I don't think pedal power is one of them. I actually learned loads about the science behind wind power and electricity, and there's loads more questions still to be answered, like, can you make electricity without using magnets? Or does solar power work if there's no sun? And remember, as a class, you too can carry out your own investigation. All you need to start is a question.
Lovely stuff, Clara. Well, we're here today with the one, the only, our amazing science expert, Mark. And it's time to do some experiments. Before we start, of course, you watching can try these too. But just make sure that you're with a teacher or an adult while you're doing them. Hi, Mark.
Hey, guys.
Well, this looks like fun.
Oh, it's gonna be fun, all right. Today, we're learning all about inertia. On Earth, everything's moving. Even when we're standing still, we're still on a planet that's rotating, orbiting about the sun, hurtling through the universe. And in order for things to move, the laws of motion describe how and why they move, just like the blades of that wind turbine. So today, we're going to investigate the first law of motion, also known as the law of inertia.
Okay.
Sounds good? Mm-hmm. Okay, on front of you, you've everything you need. We have a glass full of water, a postcard, a tube, and you will need an orange. I want you to place the postcard on top of the glass. Now, I call these do-to-do tubes. Do you know why, John?
No idea.
Do-do-do. So, let's put them on top of the glass. Now, you have to make sure that it's directly over the glass. Then, when you have that, I want you to place the orange on top. Now, a few final checks to make sure it's directly over the glass.
Ooh.
Okay. Now, in a second, I'm going to tell you to pull the postcard out really, really fast. What do you think will happen?
I would say that the orange is going to go flying off the table, and if I'm very unlucky, the glass will probably fall too.
Yeah, I have to agree. The glass is probably going to fall over.
You ready?
I think so.
Okay, we're going to pull the postcard out really fast. Ready? Okay, in 3, 2, 1.
Sweet!
Unbelievable mess! But that all worked thanks to inertia. Inertia is the tendency of objects at rest to remain at rest. That means if something's not moving, it will stay not moving until it experiences a force. You guys pulled out the postcard really quick. The toilet roll tube came with it. The orange didn't get any extra forces, so only felt that force of gravity pulling it downwards into the glass.
Amazing.
Yeah.
Okay.
Now that was pretty cool, but I'm going to do this on a bit of a bigger scale. This time, I have got 3 glasses of water. I have, instead of a postcard, a giant tray like this, which I will be placing on top of the glasses of water.
Ooh.
I will then place the do-to-do tubes directly over the glasses. And I've got 3 oranges to balance on top of them.
Mark, this is a lot of pressure now.
This is a lot of inertia, John. Okay, we are all set up here. What do you think?
No.
You, sir, are about to make a mess.
May the laws of physics be with me. Okay, in 3, 2, 1. Yes! Woo! That all worked thanks to inertia. I gave a big force to the tray. That took the toilet roll tubes with it, and I didn't give any forces to the oranges. So they remained still until the force of gravity pulled them downwards into the glasses. That also helps explain why the blades turned on our wind turbine. They didn't move until they experienced a force. The force of the wind caused them to move, which generated electricity.
Wow, well, I really was not expecting that to work, but that was great fun, so thank you so much, Mark. Now, I know you have something else up your sleeve for us for the Supersized science piece later on, so why don't you fill everyone in while we get ready to chat to Lucy?
Will do, Clara. Now, I'm very excited about this next bit. Have you ever seen someone pull a tablecloth out from under the table and everything remains in place? Well, that's thanks to inertia, and we're gonna supersize that by setting up a massive table with loads of stuff on it and seeing if John can pull the tablecloth out fast enough and leave everything in place. Do you think he'll be able to do it? Stay tuned to find out. This is gonna be good.
If for some reason you haven't heard by now, here at ESB Science Blast, we think science is absolutely amazing, and we're not alone in thinking that. There are people all over the world who love science too, and many of them have really cool jobs to do with science.
That's right. And right now, we are joined by one of those people, marine biologist Lucy Hunt, who has travelled the world and seen all sorts of amazing sea life. She's even swam with sharks as part of her job. Hi, Lucy.
Hi, guys. How are you?
Great, thanks. Thank you so much for chatting to us. Now, Lucy, what exactly is a marine biologist and what do you do?
A marine biologist is someone who studies or researches anything about the sea or something that's in the sea. And only about 20% of the ocean has been explored. Every year there's over 100 species being found in the ocean. So there's lots of more animals and things like that to be discovered in the ocean.
I heard a rumour, and I want to know if it's true. Have you really swam with sharks?
That is indeed true. I have swam with sharks. I've swam with tiger sharks. I've swam with whale sharks, the second largest shark in the world. And I've also swam with my favourite, the basking shark, off the coast of Kerry when we were doing some research there on sharks.
Whoa. Hang on, Lucy. Are you telling me that there are sharks off the coast of Ireland?
Ireland has the second largest shark in the world, the basking shark, and they actually are plankton feeders. We have over 20 species of sharks actually in Irish waters.
That's incredible. I had no idea there were so many different species of sharks in Ireland. Now, Lucy, this is what you do for a living, but for the people watching, can you explain why the sea and sea life is so important?
I like to explain the sea, it's like the engine of planet Earth, or the heart of planet Earth, because it actually allows us to live here on planet Earth. So the phytoplankton, the algae that live in the ocean, actually gives us over half of the oxygen that we breathe. So we would not be able to live on this planet without the ocean.
Amazing. So, Lucy, here at ESB Science Blast, it's all about asking questions about the world around us. So, what questions did you always wonder about when you were younger?
Yeah, I think the questions I would have asked would have been, you know, why is this fish here instead of somewhere else? Or, you know, why does the starfish want to be under the rocks instead of on top of the rocks? Wondering what's out there, why do the animals live in certain places, you know?
Now, speaking of questions, we actually have some amazing questions sent in from us from a few of the children. So first up is Eva.
What's your favorite fish to swim with and why?
My favorite fish to swim with, I think, would be the basking shark, because it's just in our backyard. It's in the Irish waters.
Okay, next up is Fiach.
Have you seen much rubbish in the sea?
So yes, I have seen quite a bit of rubbish in the sea. I think most of the time we see the rubbish getting washed up on the coast, on the beaches, and we're seeing small little plastics called microplastics on the beaches now, as well as the bigger plastics. So yeah, there is rubbish at sea, and there's actually like places called the Great Garbage Patch in the Pacific Ocean. That's where all the currents accumulate, and the rubbish will actually start swirling around in those areas as well where the currents are.
That is a shame. Lucy, next question is from Kitty.
Hi, Lucy. My question for you is, how do you tag a shark and why do you do it?
So there's lots of ways to tag a shark, but the way we were tagging basking sharks would be with a pole, and then it just has a colored numbered tag that allows you to identify the shark. And I was actually the first female scientist in Ireland to tag a basking shark when we were doing our tagging of sharks. And why we do it is to actually know where the sharks are going to and coming from.
Well, huge congratulations, Lucy, on being the first female in Ireland to tag a shark. Next question is from Ruby.
With the current level of pollution in our oceans, especially plastics, how does this affect marine life and filter feeders?
So unfortunately, the plastic is being eaten by animals. So from all different types of animals, from turtles to seabirds and basking sharks as well, will be swallowing the plastic. So we really do need to try and find ways to stop the plastic getting into the ocean.
Yes, we really do. All right, Lucy, well, it has been so cool speaking to you and learning all about the sea and your job as a marine biologist, which sounds absolutely awesome, by the way. Thank you so much for joining us on ESB Science Blast TV.
Bye.
Bye.
Well, that sounds like an amazing job. A perfect example of how asking questions and being curious about the world around you when you're younger could mean that you could end up being a marine biologist too. Or maybe you're not into the sea, but that's okay too, because science is in everything around us. So whatever you are interested in, you can probably bet that there's science behind that as well.
Right, it's time to go outside and catch up with Mark. But before we do, what we're about to do should not be tried at home. Ready?
Let's go. Oh, Mark, you made us dinner here outside the RDS. Thanks a mil.
Whoa. No.
Are we making dinner for you?
No one's making anyone any dinner. Remember earlier, we learned all about inertia.
Yeah.
Well, this is it, just on a much bigger scale. What we are going to do here is to try and pull the tablecloth off the table, and if inertia does its job correctly, the plates won't experience any forces and they'll remain on the table unbroken if we do it correctly.
And what happens if we can't do it correctly?
Well, if we can't, then I've got no plates for dinner tonight.
Oh, no pressure then.
The trick here is to pull the tablecloth down really quickly so the plates don't experience any extra forces. And inertia will do its thing and they'll remain on the table unbroken. Now, inertia can be seen in everyday life too. A great example is if you're on a bus and it suddenly stops moving, you continue to keep moving and probably bump into the person in front of you. Now we have our goggles on. Please do not try this at home. John, Clara, I'm going to demonstrate first. Okay. Are you ready? Mm-hmm. In 3, 2, 1.
Whoa!
Yeah! Now, it's up to you guys.
Okay, so we just pull it really, really fast towards our feet.
Exactly.
Okay.
I'm gonna count you in. Are you ready?
No.
In 3, 2, 1, pull! Yes! Fantastic! That was awesome. And it worked because you pulled it down fast enough so the plates didn't experience any extra forces. So thanks to inertia, they remained on the table unbroken. Well done.
Oh.
That was pretty cool. But I think we can do this on an even bigger scale. We have a bigger table with more stuff on it right there.
How are we meant to pull the cloth off that table?
Well, see, a key to this being successful is the speed at which you can pull the tablecloth out.
But how are we going to pull the tablecloth quicker?
Well, John, I think you've got the right shoes. Let's strap a harness to you. See how fast you can really run. Are you ready?
No.
Let's go. Okay, before we do it, let's get some predictions in. Clara?
Okay, I think everything is gonna go everywhere and smash, and it's gonna be a disaster.
John?
I think that table's going to be the exact same, minus the tablecloth.
All right then. And one more time, do not try this at home. Okay, John, in 3, 2, 1, go.
Almost.
Dinner time.
Well, I saved the plate and the flowers, but that's about it.
Well, that didn't quite work. Possibly because John couldn't get fast enough or pull it off smooth enough. Maybe next time we could use something faster, like a car. But that's the cool and important thing about science, that we do experiments, research, we learn what happened right, what didn't happen, what we can do better the next time.
And just next time, Mark, we might bring someone else's dinnerware.
Yeah, and Usain Bolt instead of John Sharpson.
I think so.
Well, I've broken enough things for today, but that's all we have time for here. We've had a great time investigating how wind creates electricity and if there are actually sharks in Ireland. And we have loads more questions that we'd like to investigate, like, why do we hiccup? What would happen if everybody on Earth jumped at the same time? Why do bats sleep upside down?
That's right. And remember, science is all around us. So if you've been inspired by anything you've seen today, you can sign up for ESB Science Blast at esbscienceblast.com. And you can carry out your own classroom investigations, and we'll even pair you up with a scientist to give you feedback.
From everyone here at the RDS, we'd like to thank all our sponsors, including our title sponsor, ESB, for helping us to put ESB Science Blast on every single year. Bye.